Hi there. Apologize for the delay. Let me just still setting up the stream. So what we're gonna be going through today will be the part 23 content. So here we create a buff and debuff system. Let me see if I'm able to share my screen now. Give me a moment. Right, so let's start. So I'm just gonna make sure that all my screens are functional first, otherwise we'll have to re-record this whole thing, you know. So we have Unity. Okay, I'm just gonna set up all my screens and then we can start the record. We can start talking about part 23. By the way, thanks for your support, Dusty. Okay, so here we have the article, right? Okay, let's start. I'm ready. So in this video, we're going to talk about part 23, which is creating a buff and debuff system. Let me show you how this looks like. I've prepared a scenario over here. So in the past couple of videos, we were working on a whole bunch of things, right? But the main thing that we were working on is the weapon system, which is really nice because now that it's set up, you can create as many weapons as you want, and you just gotta change stats and just write a little bit of code, and you can create many different new weapons. You can check out our forums if you want to see guides on how to create more weapons, and we'll be adding to those guides as the time passes. As we'll be adding to those guides as time goes as well. And one of the things that's missing in our weapon system, that's always been missing, and it's preventing us from creating some kinds of weapons, is a buff and debuff system. What is a buff? What is a debuff? I'll just show it to you, right? So the garlic weapon, for example, right, gives a debuff. It actually decreases the freeze resistance of enemies, and it also makes them more susceptible to knockback. Okay, so what I've done here is that for the garlic weapon, I've actually made the garlic weapon have debuffs. So it applies a debuff to every enemy that it hits. And the other weapon that we have here is the Freeze Lancer, and it's basically a weapon that only applies a debuff. So buffs and debuffs are just statuses. Okay, so another way of looking at this would be status effects. I guess probably would be a more appropriate title for this. So we're gonna cover how to create these two debuffs, a freeze debuff as well as a garlic debuff. And once we are through with this part, you will be able to create all different kinds of debuffs for your weapons, and we are also gonna allow enemies to apply debuffs to us. So this is gonna be a really interesting part. So let me just get right into it. So let me just talk a little bit more about buffs and debuffs. Okay, what is a buff? What is a debuff? You can think of them also as statuses. I just thought about it. Never thought about calling them status effects until until now. So a buff or debuff is basically a status effect, and it can be positive. So if the effect is positive, then we will call it a buff. If the effect is negative, then we'll call it a debuff. So I have some screenshots of some examples of debuffs. So the first screenshot over here, or the first video over here, is from Dota, and it's basically a character buffing himself up so that he attacks faster. The second debuff is the freeze effect, which when enemies get hit by the freeze ray, this is the Clock Rancid with a nicer effect than what you see in Vampire Survivors. So when enemies get hit by it, they get frozen, and that frozen state is a debuff as well. So you can call them status effects as well. Perhaps I should rename this part to say status effects, right? I think it makes more sense. Buff and debuff is a little bit more obscure, right? Okay, you know what? I'll figure out if I want to rename the title. So buffs and debuffs can come in many different categories. They don't necessarily have to be status effects. So for example, in Vampire Survivors, you have this pickup called the Judah Frita Tanto, which gives you a flamethrower effect when you pick it up. So this buff and debuff system in the future, when we have special pickups, can be used also to apply these kinds of special statuses, where you know you have there are a couple of special statuses in Vampire Survivors, right? There's time stop one, there is this flamethrower one, and then there is one that tracks all the gems towards you. So this buff and debuff system in the future can be used to do these things as well. So how are we gonna think of the buff and debuff system for any one of you who's played Warcraft before? We're gonna conceptualize it in a similar way that Warcraft does, where in Warcraft, statuses are called buffs and debuffs. So even the debuffs are called buffs. So we just refer to them as positive buffs or negative buffs. Okay, the shorthand for negative buffs are debuffs. So they get attached to a hero or any character actually in Warcraft for a while, and after the duration expires, then the buff gets removed from the status. So our system is gonna be similar. We are not going to create any UI for a buff system because there is no UI to speak of, right? For the enemies, for example, if you can't see their debuff, so we have to use visuals to express the debuffs that they have. So, but we will be building the buff system with this in mind, that buffs are just statuses that apply to a character for a fixed amount of time, and then they get removed after that. Of course, you can also remove buffs and debuffs if, let's say, there are special spells that help you do that, but that will be something that we'll be doing for later videos, not this one. We'll just be establishing the main buff debuff system in this video itself. So the first thing we're gonna do is to create a new buff data scriptable object. So I'm just gonna create the scriptable object, and then after that I will go through with you the properties and some of the things in the code that you want to take note of. Let me just make sure I'm sharing my screen. So let me just switch over to the project I'm going to use to share the content from part 23. And we want to create a new buff system, right? So this means that I am going to create a new folder here called buff. If I recall, let me just double check whether I'm doing the same thing in the project files. I don't want to stray too far from the content in the project files. All right, so I want to create a new folder called buff system, and in there I'm gonna create a new scriptable object called buff data. So we have many different kinds of data, right? Like we have wave data, we have mob data, we have weapon data, we have passive data, we have item data. So to follow this norm, I'm creating buff data as well. So let me just paste the script into the program itself, and then we'll go through what this allows us to do. So buff data is going to be a scriptable object, which means that there are assets that you create from here. All right, so we have all kinds of data now, right? Because we've created so many different kinds of systems, even the enemy spawning system. So we have buff data over here, and what buff data allows us to, let's say you want to create a free status. Okay, so the buff data allows us to name a buff, assign an icon for the buff. These two currently are not used because we don't have a UI to show the buffs, but more importantly, we have a type. Okay, the type is just what category this buff falls into. Is it a buff? Is it a debuff? Is it a freeze? Is it a strong? So strong is just an idea that I got from Dota that's not used. So the only two statuses, the only two types you will use are debuff and freeze. But if you want to add your own types, you can also do that. And to do that, you just have to go to buff data and find the part where it says, give me a moment, where it says, there we go, where it says type over here. And if you want to add more, for example, you want to have different types of debuff, all you gotta do is just add new items into the type over here, and you will be able to see the types inside here. After you just save this, and you will be able to see the type here. So the type is just there for us to, if you want to code special conditions for different kinds of debuffs, you can add a type to these debuffs, and then you can categorize these types accordingly. So for us, the debuff and the freeze types are important because in our enemy stats, if you recall, we have freeze resistance, and then we also have debuff resistance. Alright, so these two take into account the kind of debuff that is being applied to the enemy. So let's say if you're trying to apply a freeze debuff, then the freeze resistance kicks in and prevents the enemy from getting debuffed. So this is why we have the freeze and we have the debuff. Okay, again, you can code more resistances, and then this will allow you to, if you want to code more types in your debuffs, then you can code more resistances. And you can have things like, for example, if the debuff deals burning damage, and then you can reduce the damage and all that stuff. So later on, I'll briefly cover how you can apply these different resistances to your buffs if you would like to do that. That will be at the end of this video. So the most important thing in our buff system is the variations that you see over here. So these variations here actually allows us to control what the buff actually does. So there are a couple of things we can control. So variations are there because there will be different versions of the buff that we can apply. So for example, for the freeze buff, right, we can apply versions that have different durations. So for example, there's like if you apply the freeze buff via the Clock Lancet weapon in Vampire Survivors, for example, right, the weapon has different levels. So the higher the level, the longer the duration. So you will have to have different versions that apply the buff for different durations. So if you look at the stat we have over here, we have a duration stat. And then this changes at different levels of Clock Lancet, right? So we may have something like Clock Lancet level 1, Clock Lancet level 2, level 3, level 4, and so on. And they will all have the same stats. The only thing that is different is the duration. So level 1 is 2, level 2 is 3, and so on and so forth, right? So the effects of the buff are actually controlled inside the variations drop down here, and then you have to add different items. And there are also two stats that we have over here. Let me just move my inspector to this part of the screen so that my handsome face doesn't block it. So here we have duration, we have damage per second, heal per second. This is how much damage or heal the buff applies if you want to do that kind of thing with your buff. There is a tick interval. This is how often the tick applies. So for example, if I have a damage per second of 10, tick interval is 0.25. This means that this buff will do 2.5 damage every 0.25 seconds. Alright, and it basically, the tick interval of 0.25 means that the buff applies its damage 4 times in a second. So then this damage per second will be divided depending on how many times this runs per second. So if I have tick interval of 2, for example, this buff will do 20 damage every 2 seconds. Alright, if that makes sense. We have stack type also, so I wanted to make this buff system be detailed. So you can create many different kinds of buffs without touching code. You just have to create new particle effects. So we have different kinds of stack types. So stack type of refresh duration means that if you apply the same buff to the enemy twice or more, it only refresh the duration. So for example, if I freeze an enemy, and then after that, if I refreeze the enemy again before the enemy gets off the debuff, the new freeze status will only refresh the duration. So for example, if I'm frozen for 2 seconds, 1 second later, I'm frozen again. So then the duration will be refreshed 2 seconds again. Okay, so the effects don't stack, meaning that if I have 2 freeze debuffs and the debuff deals, let's say 10 damage a second. Okay, with 2 freeze debuffs, the debuff will still only deal that 10 damage per second. If we have stacks fully, this means that these 2 debuffs will apply differently, so to be counted differently. So the more stacks of debuff you apply, the more the damage will be. And then finally, we have does not stack, which means that if the debuff is already there, then you will not be able to apply the debuff again. So let's say if I have a freeze debuff that does not stack, this means that if I'm frozen and I get frozen again, the new freeze effect does not apply. Doesn't even refresh the duration of my status. So these are some options that you can have, and we also have modifier types of additive and multiplicative. Additive means that it just adds to the total value, and then multiplicative means that it changes the value with multiplication. So for example, if I have additive and I add a health of, or maybe I add a move speed of, let's say 2. This means that if my base move speed is 5 and my move speed bonus is 2, then the move speed is 7. But if I change this to multiplicative, then if the move speed buff is 2, this means that my base move speed is 5. 5 times 2 is 10. So this applies differently. Multiplicative is very important because this allows you to zero out the stat. So for example, if I set a modifier type to multiplicative and I set the move speed to 0, this means that I am effectively immobilizing the character. So this is really important. Multiplicative buffs allow us to apply, for example, the freeze effect zeroes out our move speed and our attack damage. So then we have to use the multiplicative modifier for the freeze type, otherwise it doesn't work. Okay, so there are 2 kinds of modifiers that you have over here for our debuffs. This is because our debuff can apply either to players or to enemies, and the player and the enemy has different stats. The player has more stats, enemy has less stats. Alright, so we will have to set 2 different sets of properties, one for the debuff attributes that it applies, or the buff attributes that applies to the player, and the other for the buff attributes that apply to the enemy itself. So what I'm going to do here is I'm just going to configure the freeze debuff. Maybe I'll just leave it. I should leave it here because I don't want to have my face block the settings that I have. So icon, I'm just going to, because for freeze, right? Let me just select an appropriate icon. Maybe from the art folder, that'll be nice. Find a weapon. Freeze. I'm gonna use this icon over here, right? But I've got to find the scriptable object again. It's under script. Let me just go to scriptable objects and create a new buffs folder. And I'm gonna be moving the scriptable object to my buffs folder right here. Did I name it buffs? Or did I name the buffs? There we go. So the scriptable object that I've just created goes in the buffs folder right here. And what I'm gonna do here is assign an icon. So the icon I'll be assigning is the blue blade thing over here, which I'm gonna use later for the clock lancer as well. The name is freeze. The type will be freeze. Okay, I'm gonna remove the 2 bonus types as well. I'll leave you to decide how many different kinds of debuffs or how many kinds of categories you want your buffs to have. If you want to have more than 8 categories, you have to remove the byte over here. This byte over here is included just to save space, because the byte basically reduces the amount of memory that the drop down, that the variable type takes up. So, but this limits us to 8 different types. If you want to have more than 8, then you remove the byte. And that's really about it. Okay, so I'm gonna classify the freeze as just a freeze, so that later we can use this to detect what kind of buff this is and apply freeze resistance to the enemies. And for the name over here, it's gonna be Clock Lancet. The debuff, I will create it later. The effect, I will create it later. So the effect over here is basically just what particle effects play when the buff is applying. And the tint over here is the color of the enemy that it takes when the buff is applied. So this one here will be, I'm just gonna have a blue color over here, and I've got to make sure to set the alpha to maximum. And then the duration will be 2, damage per second will be 0. Tick interval doesn't matter because there's no damage or heal. Animation speed is 0, right? Because when you're frozen, you do not move. So these are just a couple of settings that you can use to control the visuals of the enemy or the character that the buff is applying to. Alright, so everything is set up. So for the modifiers, I'm gonna make the modifier type multiplicative. And the health is going to be, everything is going to be 1 because it doesn't affect body stats. Only stats that it applies 2 are move speed and might, which are zeroed out. Everything else is 1. So this is how the freeze effect affects the player, and how the freeze effect affects the enemy is again move speed and damage be 0. Everything else remains at 1. Even the resistances, they're all 1. Alright, I'm just going to apply one buff because there's no need for us to create the different kinds of buff. Okay, so the main objective I wanted to do is to show you the different properties in buff data and how it works. In the code itself, there's really nothing much for me to say. It's just listing out all these variables, and the most important thing are the enums over here, because the enums allow us to have these different drop downs. And all the enums, again, I've labeled them bytes because we have less than 8 selections inside. So if you want to have more than 8 selections for any of these, you can add on new types if you want to, but you have to use, if you need these new types to be used somehow, okay, later on I'll explain where these variables are used, where these types are used, and then you can modify them to fit your own buff system if you wish. Okay, so if you want to have more than 8 options, remove this byte over here. That's really about it. If you remove this byte over here, you will have up to 32 options. If you want to have more than 32, you want to change this to log. Then you can have 64 different options. I don't want to go into how this works because this has to do with how enums work and how integers work. Perhaps I'll create a video to explain this in more detail. I think that would be useful. Then I'll link you in the video description below if I ever go get to that. So I've just explained all the properties. The explanations are in the article as well. There is a nested class inside the buff data. It's called stats. And this nested class over here is basically what allows us to have these variations over here. So this variation variable is basically just a stats object. This stats object is the stats of the buff, and basically what's inside the stats over here are what's contained inside here. Okay, so the stats section over here defines everything that's inside the dropdown. And notice also that this stats object uses character data.stats and enemy stats.stats. These are the stats for the enemies and the player respectively. And they're there because, well, they're there because the buff has to apply its modifications to both enemies and players, right? And players have a different stat system than the enemies. Okay, in an ideal world, or rather, perhaps I shouldn't say in an ideal world because vampires, whatever, it's a specific type of game, right? But in games where you have more RPG elements, you actually have players and enemies sharing the same stats. But that's for that's a discussion for another day. I personally think that it's better for players and enemies to share the same stat system. That way they can belong to the same parent classes, and when you want to modify the entire system, it's a lot easier. All right, but we have done what we've done and we have set up the system this way, so we've got to stick with it. So besides the nested class, we also have a couple of functions: get tick damage, get tick heal. These are just values that allow us to get the tick damage of the debuff. And what is this variant argument over here? This variant argument over here is because recall that we have different variations of a buff. So then this variant argument allows us to pick which variant we want to get a tick damage of. And what tick damage does is it gives us the amount of damage that it does per interval. So for example, if again, let's say my damage per second is 20, the tick damage of this will be 5. Because it's 20 times 0.25, right? That's get tick damage. Get tick heal is the same concept, but heals the character. And then finally we have get, which gets the stats of the particular variation of the buff. And the reason why this is done inside a function is because if we retrieve the value directly from the array, it's possible for us to input negative values, which will cause an error. To prevent that, there is a mathf.max, which prevents this from happening. If I put a value that's less than 0 over here, then mathf.max will convert the value to 0 and save us from an error that happens when we try and put a negative value into an array. So that's the buff data class. And now that we have the buff data class set up, you can read through the script a little bit more because I have written comments. Okay, I haven't written comments on this script, so maybe I should after this video. Okay, so you can read through the buff data. So the buff data, there's not much to it because a lot of it is just listing out the data values. And then the key is in how these values are used. So whenever we build a scriptable object, the main thing is just the variables that are made available to us in the inspector. That's the main thing I'm focused on. The next script that we're going to be covering is more important because this is entity stats, and this is the class that is going to apply the buffs. This is the class that is going to be using the buff data script to apply buffs to our characters in the game. So I'm just going to copy and paste this entity stats object into my code first, and then we'll go through what entity stats does. So again, this will be under the buff system folder in my scripts folder right here. So what entity stats is supposed to be, it's supposed to be a parent class for both player stats and enemy stats. So I'm just gonna make the necessary modifications first to player stats and enemy stats, and then I'll run through what the entity stats class actually does. So let me just find player stats and make the necessary modifications to it to make it inherit from entity stats. And then I'll explain a little bit what inheritance means. So what inheritance it entails is basically we want to remove model behavior over here, and then we want to change this to entity stats. And after we do that, we will have to make a couple of changes to our code, because what entity stats does essentially is that it handles the health of the entity as well. And the reason that it has to handle the health is because it has to deal damage. Remember that buffs, in our buff data, the buff deals damage, right? So the entity stats has to be capable of dealing damage, and the only way it can deal damage is if it handles the health. So we move the health variable over to entity stats, which means that we have to remove the health variable from player stats over here. So after that is done, because the entity stats uses a couple of functions that the player stats uses as well. So the entity stats uses the following functions. It has take damage, restore health, kill, recalculate stats, and update. So we have to find these 5 functions, right? And override them. So overriding is just labeling it override actually. Alright, so let's go to update. So update has become protected override update, right? And we will have to call base update here. I'll explain why in a bit. Okay, so I can explain why now. Okay, so the reason that we apply this update call is because entity stats, right, essentially is a class that is built to handle buffs. So we have this buff over here. This buff nested class is basically just an object that stores primarily the remaining duration of buff, as well as what kind of buff is applying, and when is the next time that this buff deals damage. Of course, it also stores the variant of the buff, because we have to, in the buff data, there are many variations, right? So we have to pick the correct variation before we can retrieve data from it. So this buff object just stores a couple of points of data regarding our buff. So later on, I'll go through the constructor and the get data when we apply the when we apply the system. So the main thing is that we have this buff object, and then basically we have a list of active buffs, and this tracks how many buffs are on the character. And then we also have buff info, which is basically just a way for weapons and enemies to control what kind of buffs they apply to the character that they are affecting at the moment. So I'll touch on buff info later on when we go into the weapons and the enemies that apply debuffs or buffs. So there are three main functions that are inside entity stats. We have get buff, which gets us a certain buff from the entity that we are dealing with. We have apply buff, which adds a buff, and then we have remove buff, which removes the buff from the list. So apply buff adds a buff to the list, and then remove buff removes the buff from the list. And we also have apply buff. We have two different kinds, but I'll talk about buff info later on. Okay, let's talk about apply buff, about the main version first. Okay, so there are two ways to apply buffs, by giving the buff data, the variant, and the duration, or by giving the buff info and the duration. And buff info is again basically just the data, buff data, and the variant. And then we have also a probability stat, which controls what is the likelihood of the buff apply. Alright, so apply buff basically uses buff data and a variant, and these two are overloads, which means that when you want to call apply buff, you can either use one of these functions. You can use either one of these functions to apply a buff to the entity that you want to apply the buff to. So when you apply the buff, notice there are three different stack types. Okay, this is because in the buff data over here, we have three different stack types, right? So here I'm accounting for three different kinds of stack types. If it stacks fully, then we just add a new buff. If it refreshes the duration only, what we'll do is we'll just grab the buff and then just change the duration. Okay, if the buff is already there, otherwise we'll add a new buff if the buff isn't there. And then we also have does not stack, which means that if there is a buff that exists, then you will not be able to apply the buff. Okay, the buff, if it's already there, then it fails. If it's not already there, we will add buff. And then every time we add a buff, we also recalculate stats, which makes sense, right? Because whenever you add a buff, then the buff has the potential to change stats, so you have to recalculate it on the player and the enemy that you're applying the buff to. Remove buff just removes the buff. It just finds the buff in the list and removes it. And yeah, so that's about it. So we have a couple of different functions over here. The reason these functions are there and they're abstract is because abstract functions only apply to abstract classes, and the entity stats class is abstract, which means that, well, you cannot attach the script to an object, which is totally fine, because what we want with the abstract class is we want to pass down the functions that the class has. So if we have an abstract function over here, this means that any class that inherits from the entity stats class will have to be able to take damage, be able to restore health, be able to kill, and be able to recalculate stats. So we have to make sure to write these functions in the player stats class and the enemy stats classes later on. The reason why we define all these functions is because update actually uses these functions. Alright, so update calls take damage to do the take damage, and it actually also has restore health to apply the heal if you have set the values to be above 0. It also uses recalculate stats, as we have seen in the apply buffs function. And finally, well, the update function is just there to track how long the buff has remaining and to do the take damage or heal the character, and then once the buff goes away, it just removes the buff itself. So entity stats basically is a class that has a fully integrated buff management system, and then we want to apply these same effects to player stats as well as to enemy stats. So then we have to find all these functions that are defined inside entity stats, and we have to override them. And then for player stats, right, the reason why we call base update here is because it is very important for us to run the update function in entity stats, because this tracks the buffs. So it counts down the buff every frame, so if you do not call update, then the buffs will never expire. So it's very important that you add this in addition to adding a protector override in front. Recalculate stats, same thing, you've got to add an override over here because it's defined inside the parent class, and you've got to find all the other functions that have been defined in the parent class and just add the override keyword. This is just a kink that C# has. And for recalculate stats itself, we also have to add something new, a little new thing here, and that is that we have to loop through all the active buffs right here. So right at the bottom of the recalculate stats function, we loop through every single buff and we apply it to the actual stats. There's actually a mistake over here because the report, right, this actually should be here. So we want to apply all the stat changes from the buff first before we update the radius. Otherwise, the radius will be updated the wrong value. So let me just update the article as well to reflect this. I didn't notice that I missed this, you know. Hi, Gentleman Gaming. Doing well today. I'm hoping to finish. Well, I'm not hoping. It's already finished. So I'm just gotta run through the content over here and then we can put together the video and push out part 23. So let me just update the stats script because I found a little bug. And this is because this section here should be right here. So if we do not make this change, what's gonna happen in the future is, oh gosh, if we do not make this change, then there will be some bugs where the radius of the collector doesn't match the actual stat of the player character. It's just a small bug, but if I do not fix this now, it's going to affect. It's gonna be hard to detect in the future, you know. So now that I've seen the bug, I thought it's just a good idea to read it out now before I get a ton of topics in the forums about why the stat doesn't match the actual radius of the collector. Where's my cursor? Ah, there we go. This. And lastly, the radius is all the way at the bottom. Okay, let me update the article and we should be able to move on. So where was I? We were just updating the player stats script, right? To updating the player stats script because we wanted it to inherit an entity stat so that it could receive buffs. So let me see if I missed any change. And then we can move on to enemy stats. So these changes are made, take damage, kill, restore health. Okay, all the changes are made, and let me just make sure there are no errors. So by making the player stats script inherit from entity stats, it also inherits all the properties in entity stats. Most notably the apply buffs function, remove buff function, and the get buff function. Okay, and when you apply a buff, of course, this applies the buffs to player stats, and we want to also define what we've done. What we've just done is to define how the buffs affect the stats, and the buff affect the stats by basically us getting the buff and getting the stats to add together. Okay, so we add the actual stats with the player modifier buffs. Okay, later on we'll modify this section, but this is something that we'll go into later on. For now, the buffs only apply additively. Later on, what I'm saying is that right now the multiplicative way of adding buffs doesn't work yet. This is because we are keeping the scripts relatively simple first. So the buff over here, for example, this multiplicative thing doesn't work yet. Later on, we'll get it to work. Okay, that's what I'm saying. Right, so next thing you want to do is to update the enemy stats script as well. So it's the same concept. We want to grab enemy stats over here and change the inheritance from mono behavior to active stats. So again, just making this change allows the enemy stats class to receive buffs. And let me just talk about also why I chose to have a super class that applies the same properties to both enemy stats and player stats. The reason I'm doing that is because I want the buff system to apply the same for enemies and players. I do not want the enemies to have their own buff system and for the player to have their own buff system. Having universal systems like that, it makes it easier for us when we want to modify the system mechanics, because then we don't have to change too many scripts, you see. Okay, that is why I made an entity stats that's like the parent to both the enemy stats and the player stats. I want them to both handle buffs and debuffs the same. So with enemy stats, it's the same thing that we've done for player stats. After inheriting the method, we will have to go inside there and start removing classes. First thing we want to do is, sorry, what am I saying? Not start removing classes. We want to go in there and start changing our scripts and labeling some of our functions as being overwritten. Okay, the first thing that we want to do is to actually, if you recall, if you look at our enemies, all right, their stats can't be set below 0 for a lot of them. Okay, for example, the health and the move speed and whatnot. Okay, but this poses a problem, and the reason it poses a problem is because we want some of our weapons to, for example, reduce the maximum health or reduce the maximum move speed or whatever, right? So what I'm gonna do is we are going to be going to enemy stats, and under the stats object, which controls the stats of the enemy, right? We are going to reduce the minimum value for these variables. So I'm gonna remove this minimum 0 restriction here, so you can set the health to be a negative value. The reason that we want to allow this is because when the stats are used inside the debuff, they should be able to reduce the move speed or reduce the health or reduce the damage. It's very important. All right. Another thing as well is we want to set the value of the resistances to be from -1 to 1. And again, that is because we want our debuffs to be able to minus the resistance of the enemy that we have. So this is because these structs are going to be used in the debuffs. They are already used in debuffs. Okay, that's why we want to change them to accommodate addition and subtraction also. And finally, we are also going to add this little operator over here. This is to allow us to add resistances together. All right, so if we add two resistances together, then we should be able to get the values of R and R2 and then just add R2 to R. So this just adds two resistances together. This is important because when we add different stats together, right? Okay, we want the resistances to be addable as well. So we're adding this logic over here so that when we have two resistance objects, we can add them together. And the reason that we want to do this is because in our stats object in the enemy, we also want to add a plus operator. This is to allow stats to be added together. This is to allow us to fulfill the part where, you know, we can add buffs together, right? Again, just a reminder, if I select the buff over here, you see there's additive. And additive is done by using the plus operator over here. Okay, later on in recalculate stats, okay, I'll show you that in a while. We also want to remove current health because health is managed by entity stats. Alright, we moved health to entity stats over here because entity stats is take damage function. Alright, so let's remove current health, and we also have to modify the code to use a different health value. So this is no longer current health, right? This becomes health. And the reason this becomes health is because the enemy has... Sorry, this becomes health because the stats here is just health, right? It's not current health, right? And what else do we need to have? We have recalculate stats. Okay, this is where the changes we have just done. There's a plane flying over my house now. Just give me a moment. Perks of living near an airbase, right? You get to listen to planes fly over your house every couple of hours. It's not fun, but what can you do? Okay, so we just added some plus operators, right? Over here under the stats object, which stores all the enemy stats, as well as the resistances object, which stores all the resistances of the enemy. So we've added a plus operator to them to express what happens when two stats objects get added together or two resistance objects get added together. So under recalculate stats, this is where we apply what we have, the changes we have just done over here, because under get resistances, we want to apply the buffs to the actual stats. So again, enemy modifier over here, okay, is a enemy stats object, and actual stats enemy stats object as well. So we are only able to do this plus operator because we have a definition for the operator here. And inside here, notice we add two resistances together. This is only possible because we have the plus operator over here. So all this makes our life a lot easier when it comes to computing, you know, adding objects together using the plus, minus, times, and divide signs. It makes it really easy for us to do our work. Otherwise, we have to write a lot more lines of code because whenever you add two stats together, notice how many things you have to add together. Alright, so this shortens the amount of code we need to do. So recalculate stats over here, remember to put override here because it's defined inside the entity stats class and we are inheriting from it. And take damage, same thing, override. It's gonna be necessary. Oh, sorry, I made a mistake over here. Take damage is gonna be a little bit different over here, right? So I'm just gonna change it to health first. And for take damage, change health over here as well. So for take damage, what we're gonna do is gonna make a couple of changes to the function because in our buff and debuff system, right, enemies will be receiving damage every time, for every few intervals. Okay, it's less than a second because our default interval for damage is like 0.25, right? Of course, you can change it so that it doesn't do damage as often. But in our enemy stats script, it was coded in part 14 that every time an enemy takes damage, it will get knocked back. And what we want to change now is that we don't want this to always be happening. And that is why we are writing a new damage function. Okay, this new damage function will have all the codes from the old take damage function minus the knockback portions. Alright, so it's gonna drop this new function over here and it overrides the original take damage function that we have from entity stats right here. Okay, so we're gonna this new function over here is just gonna do the same thing as the old function. Okay, it minuses checks the damage equals max health, and it applies Q resistance if damage dealt is exactly equals to max health. Otherwise, it shows the pop-up if the damage is more than 0, and it throws up the floating text. All this is done in part 14. Kills the enemy. Okay, so this is mostly the same, except that we are missing a couple of things. We are missing, okay, firstly, we're removing the damage flash if the damage dealt is 0. Okay, so this part over here is moved inside this section. Okay, the reason that this is done is because otherwise, if there is no damage dealt, if damage dealt is 0, we don't want damage flash to appear. Okay, does it make sense? So this is just a minor optimization of the code, and then the knockback portions are entirely removed. Otherwise, everything else remains the same. Okay, so after making these changes in our original take damage function, what we want to do is just to remove everything. Remove all these codes over here and just call take damage. So what this does is that our old take damage function is going to refer to the new take damage function to deal the damage. Alright, it's going to deal the damage using this function, and then it's going to apply knockback. So then now we have two options when it comes to dealing damage to our enemy characters. Let me just pull up Notepad and show you some examples. So for enemy, we can either deal damage to it by calling take damage directly. In this case, there will be no knockback. If I want to have knockback, I will have to specify more arguments, like for example, where the damage is coming from. So for example, damage is coming from, let's say, knockback force and knockback duration. So the main thing is if I specify a position, then there will be knockback. If I do not, then there won't be knockback. This is called overloading. Okay, so we are using overloading quite a lot because we're defining the same function, or rather the function as a function with the same name but different numbers of arguments. Alright, so overloading is useful when we want to have different ways of doing the same thing. Okay, one way for us here, take damage, one way of doing it is to deal damage directly without knockback, and the other way is we want to deal damage plus apply knockback to enemies. So what else do we have? We have the kill function over here that we have to override, and we have, and that's about it. Let me see if I missed out anything over here. Okay, we have restore health as well, which is very important, that we have to also add into our script. The reason for that is because if we do not have restore health, then our code has an error. Okay, the reason for that is because entity stats over here mandates that any class that inherits from it has to have a restore health function. Okay, so just to summarize what we've done with enemy stats, we have overridden the old functions, modified them slightly, made the take damage function be able to deal damage without knockback. That's because our buffs will be dealing damage, and we do not want our buffs to be knockbacking the enemy every time it deals damage. Doesn't make sense, right? Imagine the enemy is frozen, it keeps getting knockback. Doesn't make sense. Okay, this is why we are changing the take damage function, because every buff that we have deals damage, even if it's 0 damage, still damage. Right? And we added a restore health function as well because it's abstract, and most importantly, we have changed the recalculate stats function to factor in the buffs that the character has into the actual stats. So by making these changes, our player stats and enemy stats scripts now have the entity stats system, the buff system, integrated into them. So this is how we apply the buff system to both our players and enemies. Okay, we still have a couple of things left to do before we can test out our buff and debuff system. Okay, so we have to integrate our buffs into our weapons. That's the simplest thing that we can do at the moment. Okay, we have to implement the buffs, and then after that we have to implement also the visual effects the buffs have. Okay, but let's do this one by one. Right, so number 4, let's integrate the buffs into our weapons. Okay, for that to happen, this is going to be really simple. Okay, we're just going to go into weapon data. which is right here. And okay, what do we want to do over here? My bad, it's not a weapon data script, it's a weapon script. So in the weapon script, we have a stats object inside, okay, if you recall. And what we're gonna do here is just to find values over here and then just go into buff info, applied buffs, entity stats, buff. So what we are referring to over here, right? This is a list of buffs that the weapon will apply. And why is it that we have entity stats in front? That's because in entity stats, we define a class called buff info. Okay, this buff info class is for us to use in any entity that wants to apply buffs. So it's created just for this express purpose. So if I add applied buffs over here under my weapon, you will see that if I select any weapon inside my project, let's say, let me just go to one of the scriptable objects. Let's say I want a knife. I want my knife to apply a buff, right? I'm just gonna select knife over here, and you will see under base stats, right? We have applied buffs. And then I can just add this. And then I can assign, let's say, the freeze buff. Okay, which variant? Variant number 0. What is the probability of this applying? I'll just set it to 1. So every time the weapon, the knife weapon hits an enemy, it will apply the freeze buff 100% of the time. If I want it to apply 50% of the time, I'll just do this. Okay, so this is what the buff info object is meant to do. Later on, we'll be doing something similar to the enemy stats script as well, so that when our enemy damages our players, we can also set a probability for the buff applied. Okay, now that that's done, we have to head into, okay, so one thing to note is that the weapon, right, you will see that in under linear growth, every time the weapon levels up, it will be able to apply a buff. You can change the buff that it applies. So let's say if I want the freeze to apply different buffs depending on different levels, I can just add a new buff info over here, put freeze, and then variation 1. Okay, or I can have the same variation but different probability. This is if I want to change the stat. So for example, if I want the weapon to have a 20% chance of applying a buff, but as it levels up, it has a greater chance, maybe 40%, then I can change the stats in the linear growth section. Okay, if I do not want to change the stats of my buff, meaning I want my weapon to apply the same buff across all levels, then I will just not change the applied buffs over here and just put the applied buffs right here. Then this will apply universally to all levels. So in our code over here, we have to also account for what happens when, so this plus sign is what happens is when a weapon levels up, we'll add the stats from the linear growth to the base stats, right? So in this plus operator is used, so we have to specify how the applied buffs are applied as well. And what the logic here says is as follows. The logic says that when we have applied buffs set, okay, we will, for the applied buffs, okay, what will be the value? It'll be from the second item if it's not null. So if the second item is not specified, then we'll use the, it's not specified or if it's empty, okay, then we will use the first value, otherwise we'll use the second value. What this is saying is essentially it's saying that if there is no applied buff assigned to the level, then we will use the basic applied buff over here. Okay, if it's something is assigned here, then we will replace the applied buffs and the base stats with the applied buffs and the level when we level up to that level in the weapon. I hope this makes sense. So by doing this, we have applied the buffs to our weapons, and then it gives us this interface that I've shown you. And after we've done that, we will need to go into our weapons and make sure that our weapon applies the buffs as well. And this makes it very easy because all our weapons, or should I say almost all our weapons, because not all our weapons actually do that, almost all our weapons apply their effects by having projectiles like that. All right. So what we're going to do is just to go into our projectile script and apply the buffs on the script, which is where is this? I didn't highlight the part that the buffs are applied. Ah, okay, there we go. Highlights are here. I almost messed it up. So a lot of changes, just changes to the comments. Besides that, okay, let me just open the projectile script and show you what we... Oh, one thing I missed in the weapon itself. Okay, in the weapon, there's also a function here that I've added. And what this does is in the weapon, right at the bottom over here, I've added a new function called apply buffs. And what this does is this uses the buffs that are assigned in the weapon and applies buffs to the entity stats object. Alright. So when you call this, you have to put in either a player stats or enemy stats, and then the buffs will be applied. What are the buffs that are applied? They are all the buffs that are assigned inside apply buffs. Okay, so this function allows us to have our projectiles or our auras apply the buffs to the enemies that it damages. Alright, so this function is going to be used by our projectiles and our auras later on. It looks through all the buffs that we have in the weapon, applies them to the entity that is specified over here. Alright, so let's go to the weapons, the projectile script, which is right here. And from here, what we want to do is just add one simple line of code actually, okay, because there are a couple of lines that are highlighted in the block, but they're all just comment changes, okay. Main thing that we want to do is after taking damage, we want to also get our weapon, apply buffs to the entity that we are interested in applying the buffs to. Okay, so weapon.apply buff, because the projectile has a copy of the weapon that has fired it, and then we want to use the weapon to apply the buff to the entity. And the rest of the stuff is just changing the comments, you know. So over here, we change the comments, and then we have a give me a moment, I forgot to label the script. Modifying projectile to apply buff. I'll just add a title, projectile.cs. Crap. I wasn't sharing my screen just now. When did it start? It looks like I have to restart the whole thing. Let me just check on the stream. When did I? Oh gosh, where was I? Hi Kane. So what just happened was that I was streaming for I think a good half an hour sharing the wrong screen, so I'm going to have to re-explain some of the stuff that I just went through. So I'm gonna have to revert my code backwards a little bit. So we are recording for part 23 of the series, and I'm gonna roll back and see how far back I have to re-record, because what we have is I was explaining player stats, right? Yeah, it's just half an hour, it's fine. I just have to undo some of the codes that I've done. It's no problem at all. Thanks for joining the stream, by the way. Really appreciate it. Okay, just give me a moment, yeah. Because I need to find out where exactly I left off. Okay, let me just restart the whole thing from below the entity stats class. Okay, I've got to make sure to check my OBS Studio every couple of minutes to make sure that the correct screen is shared. So now that we have the buff data class, next thing I want to do is to implement the entity stats class, and this entity stats class is going to serve as a parent class for both the player stats and the enemy stats. And what the entity stats class has inside the script is basically it has a couple of functions, and it basically has a buff class over here, and this buff class over here is designed to mainly store the remaining duration of a buff, as well as a couple of other things, like for example the buff data, which is which buff is being applied, when should we next apply the heal or do the damage, and which variant of the buff is being applied. So this buff class over here tracks a couple of points of data regarding the buff, and when you construct the buff, later on we will see this in the apply buffs function below. When you construct the buff, it collects all this information and then it puts it into the data points that we see over here. And we also have get data, which is just a function that gets us the data of the buff that we have. All right, this is the buff data stats object, which is the stats that you see inside the buff data. Okay, so the most important thing that entity stats does is it tracks a list of the buffs that are applied to the entity itself. So later on, when we have player stats and enemy stats inherit from entity stats, what this means is that they will be able to track buffs as well. We have buff info over here, which is a class that I'll talk about later. This is, the plane is flying over now. Let me just hold for a while. Okay, so this buff info class is here. I don't know if you can hear the plane, but it's really loud in my area over here. And I don't want the audio for the video to have the planes. So when the planes are flying over, I would just prefer to not talk. Short moment. I thought planes were supposed to be fast, man. The plane is just taking forever to fly across this area. Okay, looks like it's done. Alright, so the buff info class is there because later on when we code the applying of buffs into our weapons and enemies, we will be using the buff info to apply these buffs. Okay, later on when I implement this, you will see what this class does. Alright, the most important three functions in entity stats are get buff, apply buff, of which there are two versions, and remove buff. So get buff basically gets us the buff. So basically when you call get buff, we are checking whether a particular entity has a buff. And that's why it accepts buff data, because buff data represents a buff, right? So just now we created a buff data called freeze, and we can also create different kinds of buff data for different kinds of buffs that we have. Like we can create a buff data for garlic as well. Let's say if you want to have a burn status, you can create a buff data for burn as well. Okay, so it just looks through all the active buff and it tries to find whether the buff exists. If it does, it returns the buff. Otherwise, it returns nothing. And there's also a variant here because recall that our buff data is able to record different variants, right, of a particular buff. So then if we specify a variant, it will grab the variant of the buff for us. So it checks whether it has a specific variant of a certain buff. Otherwise, it just grabs the first variant of the buff. Or sorry, otherwise it just grabs any available variant of the buff. More importantly, we have apply buff, which uses either buff info or buff data. Okay, so the most important thing we want to know when we apply a buff, we want to know what kind of buff to apply, what variant of the buff to apply, and how long the buff will apply for. Okay, so duration multiplier, this is just used later on because we have a duration stat for the player, right? So this duration stat will be put inside here. The duration stat is there to control how long a buff lasts, which is right here. Let me just open up the scene. So the player has a duration stat. Which is right here. And this stat basically is a multiplier that increases the length of the buff that is applied. So this is going to allow us later on to insert the duration stat inside to boost the length of the buff. So apply buff, whether we use the buff info version or the apply or the buff data variant, it does more or less the same thing. Okay, the buff info here, this version of the function is just here to make our lives easier. Later on, we want to apply buffs using weapons. So having two versions of a function is called overloading. We've done this quite a few times inside our buff system. In buff data, you will also see some overloads, right? Sorry, not buff data. Okay, later on we will see where have we used overloads. I recall using it, but I don't remember where is it now. Okay, later on we'll be using an overload for the enemy stats as well. Okay, if you're editing this video, please cut out the part where I mix out the overloads. Alright, so having two versions of function basically just allows us different ways of using the function by passing different kinds of information to the function itself. Okay, so the apply buff function, basically if you look at the first one, it just calls the second function. Alright, because over here it passes a buff data, the variant, and the multiplier. So in the actual apply buff function itself, right, what happens is that when we apply the buff, we go through three different scenarios. If the buff stacks fully, then we will just add a new copy of the buff regardless. Alright, so whenever you apply a buff, it'll always be successful. And otherwise, if the buff is refresh duration only, what this does is that the buff will only change the duration. Okay, that is if the buff exists. If the buff doesn't exist, then we will add a new buff. And then finally, does not stack means that if the buff exists, then we will not add the buff, otherwise we apply the buff. Right, and all three cases we recalculate the stats if the application of the buff is successful. Okay, finally we have remove buff, which removes a given buff from the character. Again, same thing, we have a variant here as well because we want to know which variation of the buff to remove. Okay, if you do not specify a variant, it will remove all copies of the buff that fit the description, okay, regardless of what variant it is. And we have a couple of abstract functions in entity stats over here. The main reason for these is because we are calling these functions inside entity stats itself. Notice that even though entity stats does not have a recalculate stats, it calls recalculate stats. Alright, because these are used by the player stats and enemy stats script. Okay, so that is why they are calling these functions. It also calls the tick damage function right here in the under update. So the update function is here, is there, and it exists to maintain the buff list, because time passes, and as time passes, you will see buffs get removed. Okay, so it's important for us to maintain a list of the buffs every time a new frame gets drawn. And then we just, every time update happens, we will just loop through all the buffs that we have inside active buffs, and then we will check whether it's time to deal damage, and then after that we reduce also the remaining duration right here. And then if after removing the remaining duration, if the value is less than 0, we'll mark the object to be removed, and then we'll use the line here to remove it. And of course, after every update and after any remove buffs, we will recalculate the stats. That's because we have to keep the stats up to date. So that's what the entity stats does. It's just a big system that helps us to add buffs, to remove buffs, and to maintain the list of the buffs. Okay, it also defines a couple of functions over here. As I've just said, it's because they are called inside the entity stats class itself. So what abstract functions? Abstract functions are functions that only can be used by abstract classes. Entity stats is abstract. Okay, what does it mean to be an abstract class? It means that you cannot attach this class to your game objects. Okay, so if I try and add a component over here, you can see that I can add player stats, I can add enemy stats, but I cannot add entity stats. This is because the class is abstract. So abstract classes are not meant to be added, they are just meant to be used by other classes. Okay, so how do you use these other classes? You use them by inheriting from it. So for example, here I have player stats, inherits entity stats. We've done this in past videos, right? So once we've done this, what we do is we're inheriting all the variables that we have here, as well as all the functions that we have, including the abstract ones. Okay, abstract ones, if you have an abstract function, it just means that the class that we have needs to implement the abstract function. If you mouse over the arrow over here, this is because there are abstract functions that we do not implement inside our player stats. So we've got to make a couple of modifications to our player stats class so that the errors are gone. One thing to note also is that I've moved the health variable from the player stats and enemy stats into entity stats as well. This is because it's a shared variable, right? Okay, both player and enemy stats have a health, so it doesn't make sense to define the health variable inside the individual player stats and enemy stats classes themselves. Okay, so what are the changes that we apply to the player stats? Firstly, remove the health variable. That's self-explanatory because it's already declared in entity stats. Next thing I want to do is to, let me just double check. Here, next thing I want to do is to, okay, we remove two variables over here because they are not used. Okay, if you check weapon index, okay, it's not used anywhere inside any of our scripts. And passive item index, same thing. So I'm not sure why it's there. It's probably just leftover of, it's just a leftover. And what else? Okay, next thing I want to do is to find all the functions that have been declared inside entity stats, because we will have to override it. So for update here, we have to override it and call base update. What base update does is it calls the update function inside entity stats. Okay, if you recall, the update function is responsible for refreshing the buffs, right? And removing the buffs when they expire. So we have to make sure to call this inside our player stats. Otherwise, the buffs on the player will not expire. Okay, so recalculate stats. Over here, what we have to do is add override. That's because we have a abstract function over here. So abstract functions are still function definitions, and we still have to override them. And after overriding them, we also have to add a little section over here. What this section does is it just adds all the buffs to the player. Right now, we are only accounting for the additive buffs, meaning, okay, over here we have multiplicative, right? Doesn't work yet. The multiplicative section doesn't work yet, so later on we will add the multiplicative functionality. Okay, right now it only adds the stats additively for the player. Okay, what else do we have to do? Otherwise, it's just listing the functions as being overridable. All right, so just got to run through the entire script and make sure that all the functions that are listed inside entity stats, they have to be labeled override like that. Okay, otherwise the code doesn't work. Restore health, same thing, override. And that about does it for the player stats script. We have to do the same thing for enemy stats script over here. So for enemy stats, we have to just run through this whole thing. And first thing, of course, is to change this to entity stats. And then we have to run through and start removing our variables. Okay, current health, let's remove that because that is managed by the health variable inside these stats, right? Right here. And then what else? What else do we have to remove? Let me just look through here. Okay, one of the main things that we want to do in the enemy stats script is to allow our stats to go below 0. Why do we do that? Because right now, if you look at the buff data, right, for enemies, okay, we are not able to set the buff to reduce health. Because if our buff is additive and we want to remove 50 health, it's not possible. The reason it's not possible is because the stats have been set to have a minimum. So let's remove this so that we can reduce the max health in the buff section. So if I remove this, you will see that I'm able to move this value below 0. Okay, right now I'm not able to do that because there are still some other errors. But later on, when I fix all these other errors, you will see that I will be able to set the value below 0. That's because I've removed this minimum over here. And for resistances, we also want to set this to be -1 instead of 0, so that we can reduce the resistance of the enemy using buffs as well. And the other thing that we want to do to enemy stats, right, is to add this plus operator to our resistances object. This is to allow us to add two different resistances together. Okay, sorry, this is the resistances. We want to add resistances operator function over here, and we want to add operator function for the stats as well. So this allows us to add two different resistances together and add two different stat objects together. Okay, so these resistances over here, notice that after adding this, I'm able to add two resistances object together. All right, and this plus operator for stats, later on we'll use it in recalculate stats, is pretty much very similar to the way that we increase the stats of our weapons with passives in part 15. And besides that, we have to go through the rest of our script and just update the health variable. Recalculate stats. Okay, this is where the interesting thing comes in. Okay, so we want to apply a similar system as the player, because we want to look through all the buffs and just add the buffs to the stats. And this is only possible if we define how the plus operator is used for the enemy stats. Okay, and of course we have to mark this as override. Public override void. And for take damage over here is interesting as well, because in enemy stats, right, we have a take damage function that always knocks back. And this is something that we do not want. So what I'm gonna do is I'm gonna overload the take damage function so that there's one version of the function that deals damage, and there's another version of the function that deals damage and knocks back. Damage function. Okay, my OBS Studio just disconnected, so let me just repeat what I just said. So this take damage function over here that we have, it's there. Okay, what this function does is that it knocks back, and we don't want our take damage function to always knock back. We want to have an option when we deal damage to either knock back the enemy or to not knock back the enemy. The reason for that is because when we have our buff, right, our buffs always deal damage. Okay, even if it's 0 damage per second, it still deals damage. So we want to have the option to be able to deal damage without knocking back, so that for buffs that deal damage, right, let's say you burn the enemy, you don't want an enemy to constantly be knocking back from the damage with the buff. Okay, so for that reason, we're gonna create a new version of the function that doesn't have knockback. And what this function contains is just the same code as the old take damage function, minus the knockback section over here. Alright. So there are also a couple of small changes, like for example, damage flash only happens when the damage is above 0. In the old function over here, damage flash always happens. Okay, which is not ideal because imagine if you deal 0 damage, the damage flash shouldn't appear. Okay, neither should the floating text appear. So besides this minor fix over here, the code's mostly is the same as the old take damage function. So we want to create a new function, a new version of the function that only takes a value for how much damage is dealt. Doesn't take knockback data. In one moment, there's a plane flying over again. These planes are pissing me off, man. Okay, planes are gone. Where was I? So the take damage function is the same as before. So now that we have this function over here, it's a different version that doesn't do any knockback. For the knockback version, we're just gonna use the version that we just created, but we're just gonna change the value like so. So we're just gonna leave the knockback section and then remove the rest of the sections over here. Okay, so we have the main version which deals damage and does all the damage flash and all that stuff. Alright, so when we use the knockback version, it's gonna do the same thing, but after that it's gonna apply knockback like this. Okay, which makes us have more flexibility when it comes to dealing damage, right? Okay, the other reason we have to implement this new function is because, again, in entity stats, we have a take damage function like this that has only one argument. Okay, so if we were to go to enemy stats and implement the take damage function with so many arguments, it's not going to work. This is why we have to define a new take damage function over here as well. So now we have two versions, so then when we deal damage, we can either deal damage to enemies by calling take damage and putting in a value, or calling take damage and putting in a value plus the position of the damage. The second option will apply. And this, having two functions, this is called function overload. Right? So when you overload it, when you overload a function and you call that function, C# will, based on the arguments that you give it, will select the best function to use for that particular scenario. So the main change really in the enemy stat script is to take damage function. And then we also have to add a restore health function as well, because if we're inheriting from entity stats, then we will have to have a copy of every abstract function that the entity stat script has, right? And finally, over here, let's override the kill function as well. And that should be all for the enemy stats script. So now that everything is changed, okay, if I go back to the buff that we have over here, I'm able to set this to a negative value. The reason I'm able to do that again is just because I removed the restriction. Okay, this is important because if I want to have a buff reduce the max health or reduce the recovery or whatever, I can set the values to negative. Previously I couldn't, and that was the main restriction. Alright, so with this, our buff system is kind of there. Okay, I say it's kind of there because we, number one, have no way to apply buffs, and number two, we have no way to see the buffs that are being applied. Okay, so the first thing we want to do is to give ourselves the ability to apply buffs. Okay, and there are two ways we can do that. We can let our weapon apply buffs to enemies, and we can let our enemies apply buffs to our player characters when they touch the player character. Okay, so let's get into that. Okay, we want to integrate buffs into our weapons. That's the first thing. Okay, so we're gonna go to the weapon script over here, and we just want to add two lines of code. The first line is the applied buffs variable. Okay, this is right under stats over here. Okay, so by adding this, okay, if we go back to our scriptable objects and select any weapon, all right, we will be able to see that there is a new variable under base stats. I've got to save this change, right? So this new variable under base stats allows us to looks like my code messed up something. Misses out the square brackets for the array. Base stats like so this should have a square bracket here. Okay, small typo in my article. Okay, so we need to add this line over here. And what this does is this actually gives us an array like this, and then we can add, let's say if you want to have our weapon apply the freeze buff, or let's say you want to have a weapon freeze and poison, then you can add a different buff called poison. Okay, you can add as many buffs as you want for each weapon. And then there are also variants. The variants depend on, of course, the variants that you have for each of the buff, right? So you can select the variants using numbers over here. First variant is 0, and then it goes from there. Probability is the chance of the buff applying. So if you want the buff to always apply, it's 1. If you want the buff to apply 50% of the time, it's 0.5. So we want to add this applied buffs variable over here so that we can choose what buff to apply and what is the chance of the buff apply. And then this will apply to all your levels as well. So for subsequent levels, only if you want to replace the buff. So for example, in level 2, I want to apply a different buff. Let's say I want to apply burn or something. I can just change the applied buff. So you leave it empty, it assumes that you're using the original applied buff. Okay, so you don't have to apply a buff to every level of your weapon. Okay, to process the applied buffs when level ups happen, you'll have to also go to the plus operator and the weapon script, and then add the logic for applied buff. Okay, so if there is no new applied buff, then we will use the original applied buff. Otherwise, we'll use the new one for the level. All right. And finally, we also have to add a new apply buffs function to the weapon. And what this does for us is that it allows us to apply a buff to an entity that we select. So the weapon should have the capability to apply buffs, and that is why we are creating this apply buffs function over here. Okay, so our weapons actually, most of our weapons use projectiles and auras. So now that we have the weapon set up to apply buffs, we will have to go to our projectile script and our aura script and apply the buffs from that, because remember that the buff for projectiles only happens when you hit an enemy, and for the aura only happens when you touch an enemy. So you have to go into the projectile script and find the part of the projectile script that deals damage, and then where it deals damage, we also want to just do weapon apply buffs and applies buffs to the enemy that we are dealing damage to. That is the change we want to make to the projectile script. All right, so it's documented in the article as well. And there are a couple of changes here as well, but these are just to the comments. Okay, the only significant change is just this line over here. Okay, the rest are just comments that we are applying to the lines in our code. Sorry, this is the wrong script. Okay. So if this is the projectile, then this shouldn't be pair key, this should be weapon apply buffs, right? Okay, so the apply buffs line actually is under here. So the only change is this. Okay, let me just update this and go back to the article. Projectile.cf. Okay, so where will we? Okay, so in the projectile script, you only need to add one line of code. That is weapon.apply buffs right here. And this applies buff to the enemy stats object that is receiving the damage. The rest of the changes just changes to the comments, so they are not really significant. The only change that matters is this line over here, right? That I've just added. I'm just gonna apply the comments from the article as well, so that the code that I have matches the article. So just by adding this line over here, you make your weapon apply buffs, and that's all we need for the projectile script. For the aura script, we want to do a similar thing where we find the part of the weapon that applies the buffs, or rather that applies the damage, and we just add this line over here. So let's find the aura script that we have in our code base and just add this line inside. Weapons aura. Okay, for those of you wondering what the weapon variable refers to, okay, where does this come from? This comes from, okay, recall that projectile and aura are both weapon effects, and weapon effects store a copy of the weapon. Okay, so with every weapon effect, there is a reference to the owner and the weapon. So then the weapon, from the weapon, you can access the weapon, and then of course you can use the weapon to apply buffs. All right, just by making the following modifications to aura and projectile, you make them capable of applying any buffs that are assigned from your weapon. All right. We also have to modify the lightning ring weapon and any other weapon in your project that deals damage directly. Okay, if you recall, the lightning ring weapon doesn't use a projectile or aura to deal damage. It deals damage directly. So for those cases, you will have to find the part of your code that deals the damage, and then apply the effect from that. Okay, so for the lightning ring, okay, we have to just find where it deals the damage. Yes, the damage. Right here, right? Where it's dealing the damage, we will have to apply the buff. Like so. Okay, so let me just make some change over here as well, because the curly braces are added. So this section over here is added, as well as this curly brace over here. So we're coming close to the end of this part, it seems. Okay, so we now have coded our weapons and our projectiles and our auras to apply buffs when they deal damage. Last thing to do before we can test out our buffs is to make sure that our buff visual effects apply to the entities that have buffs. Okay, so I'm just gonna create really simple effects. I'm gonna include a link to the videos that cover how to create the nicer version of these effects in the link in the description below. Okay, but over here, if you recall, in our buff data script, right here we have an effect, we have a tint, we have animation speed. So we have to update our codes to apply these effects to an enemy that has these settings set. All right, so the first thing we're going to do is to apply particle effects for our buffs. For that, this is going to be a relatively simple thing. Okay, for all of the modifications that we do over here, they're gonna apply to entity stats. Okay, so let's go back to entity stats over here, and let's go to the buff object, okay, which is the container that tracks the remaining duration and a couple of other things for our buff. We're gonna add one particle effect variable. right here. And we are also going to add one more argument over here, which is the owner. Okay, this is because the buff needs to store a copy of the owner that it's affecting. The reason for that is because later on we're going to have to remove the particle effect from the owner itself. Okay, so we have to store the owner. Sorry, what's going on here? We store a copy of the owner. Did we store a copy of the owner? I'm a little lost over here. Just give me a moment to sort this out. Applying visual effect buffs. Okay. We don't have to store the owner. Okay, so let me just redo this part. Okay, so we have to add a particle effect variable, and we have to add the owner also, because later on we have to specify who this particle effect is attached to. Alright, so let me just copy this part into my script, and I'll explain to you what the code here does. So we added this line. This is to store the particle effect that is associated with this buff. This is, we have to change our buff object to require us to specify who the owner is. The reason is because if the stats of the buff has an effect assigned, the stats of the buff are this object. Okay, this buff stats over here is just the buff data stats object. Okay, so we are getting the buff data over here, and then we get the stats over here, and then from the stats we check if there is an effect. If the effect variable is assigned right here, then we are going to create a new effect. And this new effect over here, right, we're just going to use the prefab over here, but we're going to create it on the owner itself. Okay, so the buff will follow the owner around. Very important. All right, so after making this change, we will also have to, in our code, right, we will also have to make sure that in our apply buff function, right, we add this extra required argument over here. So we have to go to wherever we have a new buff and just add a this object. Okay, this refers to the entity stats, right? Because from here we are inside the entity stats code. So we want the entity stats to add itself to the buff object. Okay, so this is so the buff object can later on add a particle effect to it. And we will also have to update the remove buff section, because previously we used a link function. This is just a shortcut from C# for us to remove a set of items without using a for loop. But now, because we are adding effects, we will have to replace this line of code here with a for loop, because we will have to manually destroy the effect first that's attached to the owner before we remove the buff. Alright, so this is the recorded effect from the buff. And then we have to do the same thing inside of our update function where we remove the buff. We have to replace this line with a for each loop over here. This will be expired. Okay, expired is just a variable here. Okay, it's just a list of all the buffs that we want to remove. Okay, just give me a moment. So what we've just done is we've updated entity stats to add and remove effects. We add an effect when the buff is added, and we remove the effect when the buff is gone. So we've modified the code to do just that. And we also want to apply a tint to the buff. And the tint is basically, if you recall, in part 14, or is it part 13, we've added feedback, right? Where when we hit an enemy, it will flash red. Okay, that's tinting. That's changing the color of a sprite to the color that we need to have. Okay, but now because we have buffs, okay, we have to figure out also what happens if we have multiple buffs applied to the same character. So for example, if I apply freeze and poison to the same character, what will the color be? All right, and what we're gonna do is we're gonna create a tinting system that will resolve all of these different colors. So for example, if I have freeze and I hit an enemy, right, it flashes red for a moment. So because the enemy is already blue and it flashes red, the color becomes different. So we have to create a new tinting system, and this will handle the tint that the enemy has. Okay, and this is how we apply the tint. So we are gonna just go to entity stats as well and just add a new color variable to it. Right under inside the buff class, we're gonna have a color like this. And we are going to apply the tint. And okay, let me just do the part that applies the tint and remove the tint first. Okay, so for removing the tint, you will just have to go to remove buff and remove the tint over here. And then we also have to go to update and remove the tint over here. All right, so then the question becomes like, where does this apply tint and remove tint comes from? It comes from entity stats itself as well. Okay, so I'm just gonna copy the functions and I'll explain what I'm doing with these new functions over here. So this is right under buff info, right? So for us to be able to handle the new tinting system, right, we will have to create a new set of functions that will handle all the change in colors for us. And in this new system, we're gonna have to have a new variable over here. There are a couple of variables over here that I mixed up just now. Okay, these are for the tinting system. Okay, let me explain what these variables do. Okay, they're all protected. And the reason they are protected is because they are meant to be managed by the entity stats object. They are not meant to be managed by the user. Okay, the only thing that's public is this constant over here. And this can be public because it cannot be changed. And it doesn't show up in Unity itself, because constants don't show up on Unity. Right? Constants are just the value that we use to store certain values that are always fixed in our game. So what these variables do is it stores the original color of the sprite, it stores a copy of the sprite as well, and most importantly, it stores a list of the colors that are being applied to the character at a given point in time. Okay, so if I were to go to the functions over here, first we have a start function. The start function over here is just there because we want to get a copy of the sprite and we want to save a copy of the original color of the sprite. And then we want to have two functions over here, apply tint and remove tint. Apply tint just adds a color to the list of applied tints, and then remove tint will remove a color from the applied tints. Okay, and in both functions, we call an update color function, which adds all the colors together. Adds all the colors together and it returns, or that it sets the color. Okay, so colors are basically just three different values, right? Okay, if you select the color over here, we have four different values, not three. We have red, green, blue, and alpha. Okay, alpha is just transparency. So a color has three values plus one transparency value. So by setting these three values over here, so whenever we want to add a color, we're just adding the red, the green, and the blue together to get the result. And in our tint system, we have the option to select the color as well as the alpha. So depending on how strongly you want the color to apply, you will adjust the alpha accordingly. All right. And the tint factor that we have over here is to make it so that the color is strong enough, because what this formula inside the update color does is that it adds all the colors together, it averages the color out. Alright, so the only way we can average the color out is if we average the color out, you will see that the color is always going to be quite light. Okay, so that's why the tint factor over here has a value of 4. This is to make the color have a lot more priority over the original color of the sprite. Okay, so just to recap, the update color function, it adds the color that the sprite is currently in and the color that you want to apply together and averages the colors out. Alright, but if we do that, then the colors that are applied is never going to look very strong. So then we have a tint factor over here that will affect how strong the color shows up when you apply the color to the sprite. So by adding this system over here, we have a tinting system. Okay, unfortunately for this part, all the systems are linked together, so we have to get everything done before I can show you, before you can see the results. Okay, so you have to be a little bit more patient. Okay, and finally we have also a system that will stop the animation of the enemy. But before we do that, okay, now that we have changed entity stats, right, we'll have to go to player stats, because in player stats we have a start function, right? So then we have to go here and then just do a protector override and base start. And we have to do the same thing for the enemy as well. So for the enemy stats over here, we have to make a couple of changes. Okay, so enemy stats used to have the original damage flash, and we have to replace that. So the enemy stats script used to have these because it has a tinting system as well. It makes the enemy flash a color when the enemy is hit, right? Okay, so all that stuff can be removed. Okay, so this part can be removed, and we want to go to the start function. Just do protector override, and here base start. Then we can remove the part that stores the original color, because now we want our damage system to just use the new tinting system. Okay, so that means that instead of the damage flash, instead of changing the color ourselves, we will just call apply tint, and this will be the damage color. And then after that, remove tint and remove the damage color as well. So after we have the new tinting system for buffs, we will have to switch the damage flash mechanism to use our new tinting system as well. And of course, under the kill fade over here, this uses the old sprite renderer, right? So because we've removed that variable, we have to use the variable from entity stats now, this variable over here. So this just means we have to change the variable name. And yeah, so that's done. So now we have our tinting system up, and finally we want to see when we freeze the enemies, we want their animations to stop as well, and for that we will also have to create a new set of functions to handle that. So the new set of functions are as follows: apply animation multiplier and remove animation multiplier. And we also have to make our entity stats track the animator object of our entity. Alright, so that means that we will have to declare a new animator variable right here. Animator. This animator will be saved as well under the buff. Public flow animator speed. This will be the 1 by default. Okay, before we apply the animations and stuff, we just have to in the start function get a component animator. And yeah, we have the apply animation multiplier and remove animation multiplier. When you apply it, you just multiply the animation speed by the value you give, and when you divide it, you just divide the value. So one thing that you notice is that if the value is 0 over here, it actually doesn't set the animation speed to 0, rather it sets it to a small value. The reason for that is because if you set animation speed to 0 itself, right, you will not be able to change it back by division. So 0 divided by anything is always 0. So we cannot have the animator speed go to 0, otherwise this will cause us problems. Okay, so if we go to 0, we're just going to set the value to a very small value. And when we remove it, we will also prevent the division from being able to use a 0 value over here, because again, this causes problems when we're removing the animation. Alright, so this is just the multiplication and division. And we have to update the buffs section as well, because for the buff section, right, whenever we apply a buff, you also have to change the animation speed of the owner. All right, so then we add this section over here. This is when the buff is added. All right, and that's about it, right? When we remove the buff, we will have to remove the animation multiplier as well. Same deal, right? So we remove the buff right here. We have to remove the animation multiplier as well. And now we have a working system. We can actually test out the buffs. So the easiest way to test out your buffs is to just find a weapon that you can easily access. Let's say the knife. And what I'm going to do is just add the freeze buff to it. And you will see that the weapon will start freezing enemies. Let's test this out. Let me just move the inspector back first. And I have to cycle through until I get the knife weapon. Now we have garlic. Garlic again. Where is the knife when you need one, huh? And I also have a null reference exception. What I had. There we go. So you see the buff actually applies. And right now the buff works a little weird because our freeze buff okay, there's a small little error that I have with the part 22 script because there is a bug that I haven't fixed. Gotta go and fix it for the sortable. Okay, let's. So the sortable script is caused by an error in the play movement script. And the player movement script over here needs to. Where is my player script? So over here, I need to call base.start. So this should be protected override. Start. Okay, so the issue with our debuff is as follows. Okay, right now if I freeze the enemy with the knife, you will see that the effect applies. But the movement changes and everything doesn't really work. And the enemy is also receiving damage. Alright, so the enemy receiving damage can be easily fixed because we can just go over to the buff and then we can just zero out the damage that the enemy receives. So this should be 0, right, for damage a second. So if we test out the debuff now, it should apply well, very well. There we go. So the debuff actually works, right? The problem is just that the movement is not stopped, and this is because we haven't implemented the multiplicative modifier type. The other thing you notice also is that I haven't assigned an effect. So let me just very quickly put together an effect for it, and then you will be able to see it. Alright, if you want a better effect, you can refer to our other video for creating effects for the Clock Lancer, because I've also created a freeze debuff effect as well. So I'm just gonna create a very simple effect over here. If you want a better effect, refer to that video. So what I'm gonna do is I'm going to reduce the rate over time. I am also going to change the color to blue. And I will change the particle effect here to be additive. And it has a speed of 0, start size 1 to 1.5, and a lifetime of 0.7 to 1. Okay, there will be no shape as well. And it's gonna be like this. Okay, so I'm just creating a simple freeze effect over here. And I want to make it not as bright. Maybe bright. Actually, brighter is good. Yeah. Just a really simple debuff. Just to show you that the effect also works. Okay, so we have a really simple debuff here. Let me just call this freeze. And I'll zero everything. Set the render layer to foreground so that it shows up. Alright, so it's gonna look something like this. And let me just prefab this. Okay, if you're editing this video for me, then to leave out this part, just show the, you can just speed up the process of me creating this debuff and give the link to the actual video that covers how to create a more a better freeze debuff. Okay, so we have the freeze debuff prefab over here. So I'm just gonna go to the buff, scriptable object, and from here I will just grab the freeze prefab right here, freeze debuff. So with the freeze debuff, you will see that the if I freeze the enemy, then he will play the debuff as well, which is pretty nice. Yeah, so if the enemy is frozen, the debuff also plays. Let me just try and freeze the zombie here. Why can't I hit the enemy? There we go. Zombies have a small collider, huh? It's hard to hit them. Okay, perhaps gotta fix those because the zombies shouldn't have such a small collider, right? Anyway, so we've got the debuff system working. Okay, just gotta make a couple more modifications to it. And the modifications are gonna be as follows. Let me just get back to the article. Okay, so we have a couple of minor but important things we have to apply. First thing to apply is multiplicative buffs. This is to get our freeze debuff working, otherwise it doesn't work. Alright, so let's go to enemy stats over here. And we have to add a new operator for multiplication. We don't have to add it to the player character one because the player character already has a... Do we? Okay, yeah, we have to add it to player character as well. So let's go to enemy stats first, and we have to create a new function for handling what happens when two different stat objects are multiplied. So previously we have a multiply operator, but that's between a stats object as well as that's between a stats object and a single value. So now we want to have a multiplication operator for both, where both the values are stats. Okay, so what I've copied here, however, is for resistances. So we want to be able to multiply two resistances together and two stats together. All right, so again, we have a multiply operator function defined for resistances as well, but that's between resistance and a float value. All right, so you've got to change that. So here, this allows us to multiply two resistances together. And then we also have one that allows us to multiply two stats together. The reason for that is because we have this, and the reason we have this is so that we can multiply the two debuffs together. We can multiply the stats and the debuff together. Okay, we have to add the same thing for character stats as well. So character data stats, which is right here. Wrong script. Character data. So in character data, we have a plus, right? To add stats together, we have to multiply for the stats as well. So once we have made these changes, we can go back to player stats and enemy stats and make the changes. So for enemy stats, right, we have to make the following change. So recall previously that we had a very simple way to add the stats, right? Okay, for enemy stats, we had a very simple way to add the stats, and that was just a simple loop like that. Okay, we're gonna change things up. Okay, so right now, what we're gonna do is okay, with multiplication it's a little bit more complex because now we have to create a new stats object first and set all the values to 1. After we do that, we have to go through all the buffs and multiply all the buffs together. This is only if we are having a multiplication for the modifier type. So in this loop over here, right, if the type is additive, we are still doing the same thing. We're just getting the modifier and adding it to the stats. But if it's a multiplier, what we will do is we will first we will grab the modifier and apply it to the multiplier. All right, so because we have a set of stats and we have a set of buffs, and some of the buffs will be additive, some of the buffs will be multiplicative. This means that, sorry, there's a mistake over here. What's the mistake? The mistake is this. This line should be gone. Did I cancel this lineup? Ah, yes, I cancel this lineup. Okay, sorry, let me just go through this whole thing again, okay? I have to edit the post as well because the modifier is supposed to apply before the curse buffs and such. And stats. So all of this is supposed to go behind. Okay, there we go. Okay, so what's happening here? Let me just re-explain this whole thing. So after we've added the option to multiply two different stat objects together for both the enemy and the player, we have to go back to the enemy stats script and modify the recalculate stats function. So what are we modifying here? What we're modifying here essentially is this. The original code is pretty simple because we're just adding stats together, right? But we no longer just want to add the stats together because we want to check whether the added stats are additive or multiplicative. That's number one. So this means that we have to add a switch and case statement over here to check the modifier type. If it's additive, we just add as per usual. If it's multiplicative, then we will have to multiply the value. But the tricky part is as follows. If I have, let's say the free status it sets the move speed to 0, right? So then this should take priority over the addition. So let's say if I have 5 additive buffs, and then I have one buff that sets the move speed to 0. The buff that sets the move speed to 0 should apply over all the additive buffs. So what we want to do is that multiplicative values should apply last. So to this end, right, we will have to first write some code so that we can ensure that multipliers apply last. So we will have to create a new set of stats over here that stores all the multiplicative values, and then we will do a loop. If the stats are supposed to be added, we add it normally. If the stats are supposed to be multiplied, we first save the multiplied value in the multiplier, and then we apply the multipliers last. Only if we apply the multipliers last can we have the freeze effect or any other stat effect. If you want to zero something out multiplicatively, the stat has to apply last. Otherwise, it will not always apply the stat. If that makes sense. So for that reason, the code here is a little bit more complex than what we usually have, and that's because the multiplication sections have to apply last. Alright, so we make these changes to the recalculate stats function for the enemy stats, and we do the same for the player stats section as well. Alright, so the player stats section, same thing. You want to find the recalculate stats section, and you will have to apply the multipliers like this. I didn't highlight the multiplier here. Stats. So this section here is added as well. We've got to highlight this. Multiplicative buffs. Okay, there we go. So let's just grab this. So same concept as the enemy stats section, right? We have to have the multiplier apply last, otherwise this wouldn't work. So let's go to player stats. Let's find the part of the code that the buffs are added, and let's replace this. So I'm just gonna compress all of these into a couple of lines as well, because that makes the code look much better. If everything is just chunked up like that, it doesn't look very nice, you know? And these are the cancel parts. So now we have multiplicative buffs and additive buffs applying to our enemy. Okay, so if we test this out now, we should be able to see the freeze completely stopping, because now we've added the multiplicative functionality to the recalculate stats section of both player stats and enemy stats. Alright, so let's test this out. Okay, this is strange. The freeze effect is still not applying. Oh, that's because I haven't changed the enemy modifier. Have I? But I've changed it, right? Still not applying. Did I save the enemy stats script? There's a little error over here. What's going on? Multiplicative. Why is the enemy still moving now? It seems like there are a couple of issues with my code here. The radius is set to a very low value as well. That's because I've set the magnet to 0, right? Something else should be like 1 or something. Oh wait, but the actual stats don't matter, right? My player stats have been set to 0, so let me just reset this. Oh wait, no, this is fine, right? What's going on here? Why is the magnet set to 0 in the actual game? I think it's a couple of errors that I have. It's to do with the multipliers here, right? Some issue with this. Oh, I just missed out the magnet step. 1. And this should fix the collection issue. And then we can go on to see why the enemy is not getting frozen. Okay, so this is back. This is just an error on my code. Just modify this as well. Value of 1. Okay, so let's figure out why the enemy stats are not getting modified. Is it because the curse boost should be 4? Doesn't make sense for it to be 4, right? Because the boosts are multiplicative. Let me just restart the scene, yeah? Because we don't have to make any changes to the scene. So the idea is we have to find out why the freeze doesn't apply. Right? Let's see. So this has to be before the curse boost. Does it make sense? Why does it have to be before the curse boost? Because we have the level thing as well. Base stats times curse boosted by level. Oh, you know what? I think this is right. So the curse boosts have to apply first, and the stats apply last. So my changes previously were wrong. Change everything back. So where are the curse boosts? So this has to go back to up. Back. The curse boosts have to go first. Where is recalculate stats? And curse boosts should be here. Okay, so after making the changes to the enemy stats and player stats, you should be able to see that the enemies will get the multiplicative buffs from our freeze buff. So I'm just gonna get the knife because the knife is the only weapon I have that has the freeze buff assigned. Oh, I can't believe this, man. Not getting the knife at all. There we go. So now the freeze buff should apply properly, and what you'll notice also is that if the enemy is frozen, right, he will actually not be able to damage you as well. But I've got the whip now, so I can't show this to you. Let me just freeze the zombie, and then you can see that he can't do damage when he's frozen. Okay, so that's because the damage of the enemy is set to 0 as well with the freeze debuff. Actually, it can still do damage because we haven't applied the modifications, right? So that actually brings me to the next thing I want to cover, because in our freeze debuff, okay, we are supposed to set the move speed and the damage to 0 multiplicatively. So this means that the next thing I want to do is to ensure that our attack and our enemies attacks don't do damage if the stat is 0. So let's go back to enemy stats again, and then we want to go to the on trigger and on collision stay to the. Okay, so over here we have take damage function, and what we want to do is to make a little change to prevent frozen enemies from dealing damage to us, or rather prevent enemies that have a 0 damage stat from dealing damage to us. Okay, so just want to add a simple line over here that says this: if the actual damage of the enemy is approximately equals to 0, is there a get damage? We never get damage. So if the actual damage the enemy deals is close to 0, we will just ignore the damage value. Alright, so then if we zero out the damage of the enemy, then it just won't do anything to us. Okay, this is really important. And then for the weapon itself, okay, we have to make one more modification as well. And that is that if we have, let's see, okay, under can attack over here, right? What we will do is to add one extra condition that says the following. Okay, if the might of the owner is 0, then we will also not be able to attack. So this is going to be really important because under the free stat, right, for both our player and the enemy, we will just zero out the move speed and the might for the character and the move speed and the damage for the enemy. So this makes it so that the enemy or the player is no longer able to move or attack, which is what freeze does, right? So then by doing this, we will make it so that when we are frozen, none of our weapons will fire. And for the enemy, when they are frozen, they will not be able to deal damage to us. Okay, I think this is pretty important to implement into our stats. And finally, we have to implement enemy resistances. Okay, what are enemy resistances? Remember, we have a freeze resistance and a debuff resistance. And for now, it doesn't apply. And the reason it doesn't apply is because we haven't factored these into our calculation. So recall that we have entity stats over here. We have an apply buffs function. And this apply buffs function, right, we can actually override this by going to enemy stats and just putting in our own version of apply buffs. So in this function over here, right, this is just going to call the original apply buffs function. But before we do that though, we want to do the following. We will want to check if there is freeze resistance, and if there is freeze resistance, we will fail to apply the buff. Alright, if there's freeze resistance is greater than 0, before we fail to apply the buff, we will randomly generate a value between 0 to 1, and we will check it against our freeze resistance. So let's say if we have a freeze resistance of 0.3, this means that we have a 30% chance of skipping the freeze. Alright, so then if the value here is less than 0.3, which is here, let's say our freeze resistance again is 0.3, then this will fail, then this will return false. Alright, so only if the freeze resistance is, sorry, what am I saying? Okay, let me re-explain this. Right? Random.value gets a value between 0 to 1. So our freeze resistance here, let's say if it's 0.3, right? This means you have a 30% chance of ignoring the freeze. So in this case here, if we have a 30% chance, it means that the value here from 0 to 1 has to be below 0.3, otherwise the freeze will work. So if the value is below 0.3, the freeze won't work and will return false. This means that the buff doesn't apply. So this only works if the buff that we have is a freeze buff. And over here, only if the value that we have is a debuff, then we will check the same calculations and then we will see whether we are able to skip the debuff or not. So by overriding the apply buff over here, we can factor in freeze and debuff resistances for the enemy before we actually go on to applying the debuff itself. Alright, there's quite a bit of math over here. Okay, but this is a really it's a really scalable way for us to apply resistances. So in the future, if you have different kinds of resistances, you can just add more conditions over here to allow the resistances to apply to different kinds of debuffs. And if you want the debuffs to apply to the player as well, let's say you want to add some resistance stats to the players as well, then you can also copy this apply buff function and put it into player stats, and then this will give the player some resistance, some probability of ignoring the debuffs that are applying to it. And finally, we can also allow enemies to apply buffs, and to do that we want to go to enemy stats again, and we can just add a couple of lines of code. Okay, attack effects is one of them. Again, this is buff info. So in the enemy itself, right, when we use the buff info, we don't have to put the entity stats. That's because the enemy is a child class of entity stats. So we just have to use, we can just use the class without specifying the class that it belongs to. So I'm just going to put it right here. And then if I hit down further into the part where the enemy damages us, which is under on collision stay, after dealing damage, then we can just apply the buff like this. Alright, so by adding these two lines of code, I can now go to my prefab. Hi Cam, sorry I missed your message. I was trying to get all to go through the entire article, and I didn't think it would take so long. So sorry I missed your message. So once we add these, we can go into the prefabs section. And if we go to our enemies over here, right, there is a attack effects now that we can assign buffs to. So let's say if I want my bats to freeze my character, for example, then I can just add the freeze debuff over here and set the probability. So let's say if I want there to be, say, every bat has a 40% chance of freezing my character, then I'll just add this to the attack effects of the bat. And now when the bat touches the player, you will see it applies debuffs sometimes. See that? And then when I'm debuffed, I will not be able to move. So that's almost certain death, I think, because I can't attack. So probably freeze debuffs are not the best. Let me reduce the probability and see whether this will save my life. Why does it always apply? Shouldn't it be only a 10% chance? What if I put 0.0? I'm just checking to see if the probability thing works, because it should work. So it doesn't always freeze me. There we go. That's when the freeze happens though, it's so fatal, right? It doesn't. If it's 0.2, it applies more times, right? I think with Aura, it's hard to freeze the guy because you kill the bat before it can freeze. So the reason why the freeze is so merciless, right, is because the attack effect applies every frame. So probably you shouldn't be trying to freeze your player when you shouldn't be trying to have your enemies freeze your player, because it's a pretty fatal thing. But there you go, so you can have your enemies apply debuffs as well. And yeah, so that's about it for this part. So in this part also, I've created a debuff for the garlic, which I think is pretty important because the garlic is supposed to have some debuffs, right? So this will be in the project files. I'll just show you the statistics for the garlic weapon. So for the garlic weapon, we have garlic buff data as well. And the buff data are as follows. It's additive. Stacks fully. And the reason it stacks fully is because the duration is 1.3 seconds and the cooldown of garlic is 1.3 seconds as well. Okay, so it makes sense. If you can get multiple stacks, then you'll be able to get very low freeze resistance on the enemies. It's not a multiplier of 0.3, so it adds 30% more feedback every time you affect this an enemy with the status effect. and also there is the freeze resistance over here. So I forgot to go through the knockback multiplier portion because we have to change our code for that as well. And did I do that? I don't think I made the change for the knockback multiplier, right? Let me see, knockback. Oh, so there's one thing I missed out, and that's the knockback section. That's under movement, right? Player movement. Enemy movement. Sorry, it's an enemy movement. So I've got to change the article then because I missed out the part. I missed out that part that handles the knockback. And I think I also missed out the part that increases the duration of the debuff, right? Based on the stat of the player. Under weapon, we have apply buff. There we go. So one thing I failed, a couple of things I failed to factor in. Number one is apply buffs. When we added a code, we actually also threw in the duration. This duration is the duration stat of the owner. And basically what this does is it multiplies the buff duration, because if you go back to entity stats over here, there is a duration multiplier and apply buffs, which is right here. So then this will cause the buff to apply with a higher duration, which is really important. I just noticed another bug. So this over here should have duration multiplier as well. So let me just modify the article. Remaining. So yeah, it does. Feels good and everything works, but it doesn't always happen that way, unfortunately. Well, I hope I was recording the last couple of moments. Was I? Okay, that's great. Because I spent half an hour re-recording some stuff. Because I forgot to change my screen. Okay, the last thing I want to cover in this stream before I wrap up is for the knockback function, right? This has to take into account the knockback multiplier stat. Oh, which is already there. I guess I'm done for this stream. So I haven't decided what to do for the next part. Because I had some ideas for some bugs I wanted to fix, but I forgot what they were. So what I'm gonna do is I'm gonna just compile the project files for part 23. I'll post it on the Patreon together with this video, and then we will start editing and cutting out the video for part 23. And if I don't remember what I wanted to do with the next part, then what I'll be working on next will be improving the map generation system. And after that is done, then we should have a pretty robust core set of mechanics for the Vampire Survivor series. So thank you very much for tuning in. And well, I'll see you when I see you next week. I'll try and do a stream, I think Tuesday. And the video will take a couple of weeks, probably next week at the latest it'll be done. I'm hoping by next week it'll be done. Then I'll see you around.